Okay, good. You are still there, right? You can hear me, right? Okay. Yeah. Okay. Good. Yes. Great. All right. So I hope you all have downloaded the file I sent you, and I would like to share the screen here. I have downloaded, and let's take a look at what we have stopped last week. All right. I think it's time, 8 o'clock already. Yeah, I think most of you are here already. All right. So very quickly, because it's already been 2 weeks almost. So I will revise what we have stopped previously. Now remember the tips I give you and I ask you to write down right now. So I will very quickly go through the steps and then you just follow the method. Okay, you just follow the method. I don't know why this keep bugging. Okay, now let me open the whiteboard. Okay, you should be able to see the whiteboard here. I'm going to write something here. Okay, now very quickly, you're going to revise how to prove trigo identities. So these are the very basic stuff we need. We shall start with tangent, all right? Now, as I mentioned before, I will always say tangent is sine over cosine. Obviously, you have to tangent the angle, right? You cannot tangent nothing, correct? So you have tangent and you have cotangent, right? So your cotangent is a reciprocal of tangent. So you will always change to cosine over sine, right? Remember what I told you last lesson? And then you will have this thing called secant. When you see secant, how would you remember? The third alphabet is C, right? So I did mention to you is 1 over cosine because cosine start with C as well. It's very irritating. Okay. All right. And then you have cosecant, something you're not too familiar with. You're more familiar with sine, cosine, tangent, right? So whenever you see cosecant, you look at the third alphabet, you're going to change to 1 over sine. Because the third alphabet is S, then you can see the sign over here. So basically, what you need to do is to change all the, you should see, change all the tangent, cotangent, secant, cosecant to sine over cosine, cosine over sine, and so on. Everything change to sine and cosine. You understand what I'm talking about? Now, after you have changed everything to sine and cosine, you try to use this formula. You try to use this formula. Okay, sine square x plus cosine square x equal to 1. Now, this is the most important identity in trigo, all right? Of course, you have the other two. Very quick, I'm going to go through this. Now, I did tell you, you remember these two hand in hand, right? So when you get secant, what you do? You add a core in front. Remember what I told you? You add a core in front, you add a core in front, then what you get? You're going to get cotangent, right? You're going to get cotangent and you're going to get cosecant squared. Correct? So then you get the other two identities. Understand? No problem, huh? Now, after all this, what we had previously, remember what I told you about sine, cosine, all you need to do for the compound angle here. So you remember what I said? Sine, cos, cos, sine. That's how you remember it, right? Sine, cos, cosine is like that, dancing right now. I say left to right and then right back to left. Sine, cos, cosine. Now you see plus, you put plus. When you see minus here, and then you put minus. Understand? So this is how you get your compound angle here. Okay, the next thing, the same thing you're going to do for cosine. But what happened to cosine? What happened to the addition? Is cos, cos, sine, sine. When you see plus, you put minus. Is that okay? When you see minus, you put plus. So it's actually cos, cos, sine, sine. Is that okay? All right. So remember how I try to figure out what is sine 2a. Now sine 2a, you simply make the b equal to a, right? Once you make the b equal to a, don't you think that you'll get sine a plus a? That's how you get sine 2a. So what did I tell you about sine? Is sine cos cosine, right? Now sine cos sine. Just now was b, right? So b changed to a, so you get sine a, cosine a, sine a, and you add them up. Now, don't you think these two are the same? That's why you get 2 sine a, cosine a. Understand now? Now, 2 times 3, isn't it the same as 3 times 2, right? So that's what I mean. Your sine a, cosine a, sine a, actually they are the same right now. So it's 2 times of sine a, cosine a. You see the sign here? Sine comes first, right? When sine comes first. Now that's how you get your double angle formula. You get your double angle formula by changing the b to become a. Then everything, all the b you can see have changed to a, and that's how you get the double angle formula. All right. Now I understand that I'm going through quite quickly. No worry. When I come to trigo identity, I will remind you again how to get your double angle and so on. Okay, now let's move on to cosine. Now cosine is the very tricky one. You can see that cosine have 3 outcomes, right? Remember I told you you have 3 in 1 coffee, you have 3 in 1 shampoo. Now cosine have 3 in 1 also. So when you have cosine a plus b, same thing, you're going to change your b to a, right? So you have cos, sine. Understand? So you get cos a, cosine b, and then you minus sine A, sine B, right now? That's what you get for this. Now, what happens if you change the B to become A? All the B on the right-hand side will also become A as well, right now? Correct? So once it has become A, what have you gotten? Sine square A minus cos square A minus sine square A, right now? Because this one is already has changed it from B to A, right? So you have changed to B to A, then you cosine is cosine square A, right? Then you get sine square A. So this is the first double angle formula you are getting. This is the first double angle formula you are getting, right? So remember the most important trigo identities I told you the previous lesson. I even give a name, right? Remember the name? I say this is the bridge, right? This is the bridge. Sine square A, sine square x plus cosine square x equal to 1. And it is the bridge across what? Sine and cosine, right now. So if you want to change sine square, cosine square, you just simply put the cosine over. And if you want cosine square in terms of sine square, you just do this. Understand? So this is a bridge between sine square x and cosine square x. So if you want to change everything to one type of trigo function, you just simply use this trigo identities. All right? Okay. So because of that, you can change cosine to 1 minus sine square, isn't it? Like this one. This is what I have mentioned here, right? So you just replace the cosine with 1 minus sine, and you get the second double angle formula, which is 1 minus 2 sine square A. Understand? So that's how you get the double angle formula for cosine. That's another double angle formula for cosine. One last one, you know where I'm going to get it from, right? Now, one last one is going to change the cosine to cosine. Okay, I better use another color. So for this one, I changed it to 1 minus cosine square x, but must bracket it, must bracket. So I will get cosine square A minus, and then eventually I get the third double angle formula here. Let me erase this. Okay. And then this is what I'm going to get. I'm going to get 2 cosine square x minus 1. So that is my double angle formula. All right. So there are 3 of them. So what have you noticed? You notice when you have double angle for cosine, when you have double angle for cosine, you will start with cosine. When you double angle with sine, you start with sine. Can you see the sign here? Let me highlight it to tell you what I mean by this. You can see this over here. You can see Sine 2a is sine, right? So you start with sine. Can you see the sine A here? When you have double angle for cosine, you start with cosine. You see, you start with cosine. 2 cosine x, isn't it? Starting with cosine, cosine square x. Cosine started first, right? You want sine can, but it actually has to be later, right? Now it's 1 minus 2 sine. So all these are the double angle formula for cosine 2a. Double angle formula for cosine 2a. Double angle for cosine 2a comes in 3 different types, okay? 2 cosine square A minus 1, cosine square A minus sine square A, and 1 minus 2 sine square A. Understand? So you have 3 of them here. Is that okay with you? So these are the 3 double angle. Now don't worry. In the exam, I make sure you can find the correct one. Okay, I will give you tips as we go through the example. How to look at the correct one, how to choose the correct one. You have no time to try and error in the exam. You must get it straight away. Even there are 3 possibilities. If you do more, you will know. Okay, you will know. Okay, maybe I should start with some examples. I do not know whether you have time going through the question I send you. Okay, let's go back to the question I sent you and we try them out. Okay, we try them out. So what are the tips I gave you? Change everything to sine and cosine and try to use sine square x plus cosine square x equal to 1. Okay, so this is the most frequently used formula, and then most probably you'll be able to get the answer. I have shown you some example last week, and maybe we should continue where we have stopped, right? Last week. Okay, I did send you some question. Let me go through the files again. And I put it back here. Where is, let me check, give me a minute. I think it's here. All right. Okay. Let me take a look. These are the questions I've shown you, right? Last week. Okay, I believe I have done question 5, question 13. Okay, using all the same type of method we have here. Have I covered 21? I think I have, covered 21 also, right? Let me see. Okay, doesn't matter. Okay, let's try again 21. See whether the method I shown you last week, whether you can still do them. Now, let us do it together, okay? If you can do faster, you go ahead. But if you do a bit slower, doesn't matter. And you try what I have told you, see whether it works for you. All right, now let me copy and paste over here. Okay, I just wanted to prove some identities together with the question I have sent you. All right, just a moment ago before the lesson. Okay, let's try this out. See whether you can get it out. Okay. Wait, you should be able to see here. Come, let us do together. I'm sure you have your paper, pen with you. Okay, you can see the files I'm sharing. Now, what did I tell you? Now, the first thing you have to decide whether you want to prove from the left-hand side to the right-hand side or vice versa. Very obvious, right? You have more items on the left-hand side. You should always start from the left-hand side. Come, let's do together. Left-hand side, right? Now, since already sine and cosine, you don't see cosecant, cotangent, all this stuff, you just leave it as it is. Now, what did I tell you when you see something like that? You see a fraction, right? And then you see another fraction. Now, you don't think this as trigonometry. If I give you a number, what do? Of course, you take common denominator, right? Now, I'm sure you know how to take common denominator. You multiply what you don't have. You have 3, you don't have 4, because the common denominator is 4 times 3, right? So you multiply what you don't have. Correct? So over here, once you see 2 fractions, obviously you got to take common denominator and merge them, right? That's what I told you last week or the last lesson. You can see here. So you multiply what you don't have. Over this fraction, what you do not have is sine, right? So you multiply the sine. Over here, what you don't have is 1 minus cosine, then you do the same thing. Now you have the common denominator. You draw a straight line and you see sine theta 1 minus cosine theta as your common denominator, right? Yes or no? Sorry, I'm not very used to the tablet. My handwriting is not good. Okay. Now, what do you get after that? You get sine squared theta minus bracket 1 minus cosine theta. Now, would you say that, oh, dear, I'm going to get stuck here. Now, what did I tell you before that? When you get stuck, what do you do? What did I tell you? Remember, I said use the very important trigo identities here, right? So what do you do with sine theta? What do you do with sine theta? You make it sine squared theta equal to 1 minus cosine squared theta. How do you know? How do you know you need to replace this? How do you know? Because this is the only bridge you get, right? From sine square and cosine square. You cannot change this one right now. You know what happens if you want to change this? If you want to change this, then you got to square root, right? I hate square root, and you know something is wrong, right? Correct or not? I mean, how to prove identity with a square root out there, right? Correct or not? So obviously you can't change the cosine. The only way you can see is sine. And I told you before, you change to one type of trigo formula, trigo functions, and then you can see obviously you need to change sine square to cosine square so that you have cosine square on top, right now. So what you get here, you get 1 minus cosine squared, right? Not x, theta. So used to writing x. Am I going too fast? And then you multiply this in, and what you get? You get minus 1 plus cosine theta. Then you should be very happy. You know your answer is coming out already, isn't it? Because the 1 is being cancelled off. Can you see? Slowly, slowly. Continue here. Can you see the 1 and negative 1 is going to be cancelled off? Can you see or not? Now, then you should be very happy. You cancel this off. You know your answer is coming out. And then what do you get? When you see something like that, very obvious you need to factorize right now because you take a look at the right side. Correct? You take a look at the right side. What do you expect? Like what I told you before last week, right? I know you need to prove from the left to the right. Remember, you need to prove from the left to the right. But if you get stuck, what do? You just stop there. Is that okay? If you get stuck, you just stop there. And you start from the right side. You take a look at the right side and ask yourself, am I on the right track? You look at the right side. Your right side is cotangent, right? It does help you, all right? Because that is your guideline. That's your direction. You can take a look. Your right side is cotangent. Now, what did I tell you in the beginning of the lesson? When you see cotangent, what you do? You change to cosine over sine. Yes or no? Correct or not? So you just start from the right-hand side, right? You move to the left. Correct. What do? You know you can do something with cotangent, right? Remember I told you, you change everything to sine, cosine. So what do you get? You get cosine over sine. Now you're a step nearer to this already. Now let me erase this. I don't want to confuse you here. So you understand why I choose sine square and cosine square. This is the bridge between sine square and cosine square, right? You just get rid of the cosine, you get rid of the sine square and change it to cosine square, and you know your answer is coming out over here. Slowly, So you get cosine squared theta plus cosine theta here. Yes or no? I got no space, but right, I supposed to write equal on the left side. I don't like to write equal all on the same line. So please write all the equal sign on one side only. Don't write like that. Or maybe I just write down. Yeah, write the next line. Can see still, right? Can still see this. Minus cosine square theta plus cosine theta. And you know after you factorize out the cosine theta, you can somehow cancel this right now. Cannot. Right? Understand? So 1 minus cosine theta. And then, of course, I got no more space. I will write at the next line. So maybe I just go up. And then you can see this cosine theta minus cosine square theta over sine theta 1 minus cosine theta, and then you just take out the cosine theta and you get 1 minus cosine theta, and you know this is how you get the answer. Isn't it easy? Easy, right now? Cannot. Easy is SOP, standard operating procedure. What are the standard operating procedure? Whenever you see anything that is not sine and cosine, you change to sine and cosine. Since they are already sine and cosine, so leave it. Whenever you see two fractions, you take common denominator, right? Standard, isn't it? Isn't it standard? You've been doing that for algebra right now. Then you take a look at the right-hand side, and then you can always go back from the left, continue, all right? Because that will get you a step closer to the answer if you get stuck here, right? What I mean is if you get stuck somewhere here, then you start from the right-hand side, you know that you're supposed to get cosine over sine, isn't it? After canceling this, you actually get cosine over sine and you go back to cotangent theta. Okay, so how do you find this? Is that okay? Now, like I mentioned before, you do have a handphone with you, I know. To save time, I don't have to keep asking you and then give me a thumbs up one. Okay, you can just show me 1 or 0. 0, that means you still have problem. You need me to explain, you can message me through WhatsApp, or you can put in the chat, okay? But if you put 1, that means you're okay with it, then I move on. Is that okay? You understand what I mean? You can put in the chat group, or you can put 1 in the chat group, or you can put 1 to send it to private message me. Okay. Okay. If you have no problem, I'm going to move on. I'm going to move on. Okay. Am I going too fast? Now, this is what I've covered already last week, I believe. Okay, let's move on to the next question. All right. Now, don't worry about it. If you still have problem, you can always stay back like what I mentioned. Stay back for a while after lesson to clarify your doubts, okay? All right, now let's go back to the question we have just now. Okay. Where is the file? I always lose my file. Wait, I think we can start here also. Give me a minute. Here. Now, I did send you some question, right? We can try. You can try. This also, these are very simple one. Let's try together. Wait, now you see whether the method I teach you works for you. Hold on. Okay. Let me paste it over here. Okay. Those of you, you can continue doing. You can do together with me. And then these are the simple one. Okay. Right, because some of you are still not too familiar with it, then we can try this out. Okay. Now, see the file I'm sharing here, or you can take a look at the WhatsApp. Okay, come, let's start. Now, what is the first thing you need to do here? Remember, I put this most important formula next to it. No problem remembering this, right? Sine squared theta plus cosine squared. Now, I told you before, there are 3 types of, all come from the same formula. I call this one formula. I don't call this 3 because all come from this, right? All come from this. I just shift over. Now, okay, this is what you have. This is the most important formula you have for trigo identities. Now, let's start from the left-hand side. Now, again, how do you know you need to start from the left-hand side, right? You take a look at the right-hand side. What can you do? You tell me. Nothing much you can do unless you're very good at double angle, okay? Unless you're very good at double angle. If not, I'm sure you can do something with the left-hand side. When you have a square, what do you do? Remember how you spend your secondary 2 algebra? Your sec 2. You have only this formula right now, correct? A plus B, A minus B equal to A squared minus B squared. Yeah. So when you have a square, you just cosine square minus 2 sine x cosine x and then plus cosine square x. You see? So easy, right? So this is the left-hand side. You know that when you have a square, you can do something about it. When you're already here, what can you do? You don't go backward. It's quite difficult, okay? Unless you're familiar with the double angle formula, okay? I don't suggest you do that. You definitely can expand this using the algebraic identity here. So like what I mentioned, what is sine square plus cosine square? Isn't it equal to 1? Your answer comes out already. Well, only 2 steps. Super easy right now. Correct? Too easy already, right? Okay, now how about B? Come, let's go on. Let's move on to B. I think I can erase this. You try to memorize it. It's not difficult. It's quite easy. Don't mention the angle. Just say sine square plus cosine square equal to 1. That's it. 1 and 0, they are very special numbers. Unique and special. 0 and 1. These two very important numbers. All right. Okay. Come. B. Very easy one. What did I tell you when you see cosecant? Look at the third alphabet, right? 1 over sine, isn't it? Correct or not? So you know you want to change everything to sine and cosine, right? Now, what did I tell you when you get a fraction? What did I tell you? You take common denominator, right? Isn't it what I told you? It's the same thing, right? Not? That's why I told you is SOP, standard operating procedure, standard. So once you take common denominator, what you get? You multiply what you don't have, right? Over here, of course, you already have 1, right? So you multiply sine. You don't have sine, right? So you just multiply sine, 1 minus sine square, right? Isn't it from the formula? Cosine square x is 1 minus sine square x, right? So you just change it to cosine square x over sine x, isn't it? So what do you think? Cosine square x, isn't it cosine x times cosine x, then sine x, right? Correct or not? So you look at the right side. Where do you get the cotangent? Where did you get the cotangent? Your cotangent gotten from cosine over sine, right or not? Correct. And that's the answer already. 2 steps also. Super easy, right? Cannot. Am I going too fast? Super easy, right? It's too easy already. You get the answer here. Right? Cosine over sine. And this is a product. That's why you can do this. There's no plus minus. It's a product. That means it is a multiplication. Okay, that's it for B. Okay, now? Cannot. Cannot, you better tell me. Okay, this is really too easy. Okay, let's do C. I always start with something simple. Then later I get you a little bit harder and more challenging one. Okay, try. What can you do with cotangent square x minus cosine square x? Over here, can you do anything about it? What did I tell you? Cotangent. Standard procedure. You will change to cosine over sine, right now? Yes or no? Because you have a square, so you square the numerator, you square the denominator, and then you get cosine square x over 1. Same old story, right? You got 2 fractions, what you do? Take common denominator. TCD, right now. You take common denominator, right? Okay, come, let's do that and see whether you get something like this. Multiply sine square, multiply sine square. Yeah, so what you get? Okay, slowly. You continue, please. Can you see the cosine on the right hand side? So what do you expect? Of course, you don't just keep looking at the left. You must take a look at the right, see whether you are heading towards the correct direction or not, right? You don't chong anywhere, right? You take a look whether the general direction is correct. Look at the right side, right? Then you look at the right side, like what I told you. If you get stuck somewhere here, what do you do? What do you do? Look at the right-hand side. You know your right-hand side has cosine, so you better factorize out the cosine, so at least you get one item correct, right? So you take it out, you get this, yes or no? Right? How do you know you need to factorize? How do you know you need to factorize? Can you see? You take a look at the right-hand side, you know you need to factorize. You take a look at the right-hand side. Because you know your cotangent, what did I tell you? You must change to cosine square over sine square, right? Cotangent. So you know definitely you have these two items with you. Don't you think you already gotten them? Can you see or not? So whenever you prove until you get stuck, you take a look at the right-hand side. Then you move from the right to the left. You understand what I'm talking about? You move one step or two steps to the left, and then you meet somewhere. Oh, that's it. Then you get the answer. So what I mean is you move something here, and then you try to move over here, and then you continue from here. If you can't move forward, you move backward, and then you continue from here, go backward, isn't it? I mean, if you can go forward, you can go backward, isn't it? Then you can go all the way until here. This is what I mean. Understand now? So if you get stuck here, you just try to move from the right to the left until you meet the same place, right? And then you just go backward. All the way from the left to the right, you just copy, go backward, right? You can see from here. If you get stuck here, how do you know you need to factorize? Take a look at the right-hand side. The right-hand side already have gotten your cosine square, right? So you understand you need to factorize. So once you factorize, you get the answer. So that is the answer already. Isn't it? Correct now? Because cosine over sine is cotangent. That's how you get your cotangent square x, isn't it? Then 1 minus sine square is cosine square. That is the formula that I said is the most important identity in trigo, right? Isn't it? Correct. Because I've done so much already, I can tell you what you need to do. How you approach the question so that you can prove identity easily. Later, I show you how you can make use of the double angle, especially for cosine 2a, you will definitely be able to choose the correct one. Even there are 3 possible outcomes. I will show you how to choose the correct one, 100% correct, okay? Don't have to try all the 3, all right? You don't have the time. All right, I hope this is good for you. By the way, I have already done C. These are easy one, Is it okay? Okay, I better stop here for a while. Are you okay with this? Anybody send me anything? Nobody. Does it mean that it's okay? All right. No response now. Okay, if it's okay, send me one. Okay, at least I know you're okay, right? All right. Okay, we can do D, we can do D. If not, I'm going to continue, because these are too easy. I don't know, waste time here. Okay, come, let's do together. Same thing. Now, isn't this almost the same as the first one, right? You tell me how to start from right. What idea do you have? You got no idea. What can you do here? You can't do much, isn't it? What can you do? You tell me. But you start from the right, at least you know you can do something. You have a square, you know you can expand, right? You see cotangent, you know you need to change to cosine over sine. You see, this is what I told you, right? So you do something, you do on the side that you can do something. On the right side, what can you do? What idea do you have? No idea, right? How to prove from the right to the left? It's very difficult, right? Unless you think about conjugate, maybe you can think of conjugate, 1 minus cosine, and then why you want conjugate? Okay, there's a reason why you put conjugate. You can remember what conjugate? Remember your cert? This is a conjugate, right? You multiply the conjugate pair. A plus B, A minus B, that's conjugate. What's the reason you use conjugate? So that you can get 1 square minus cosine square, right? A square minus B square, so that you can get sine square, isn't it? Unless you think about that. But still very difficult to get the left-hand side. So it's definitely easier for you to start from the left rather than start from the right. Starting from the right is quite hard. So, okay, first skill you need, you need to prove trigo identity. You want to approach in the correct direction. You must know whether you should prove from the left to the right, right to the right, left, which way is easier, all right? Of course, your teacher can tell you, the one with the more items. Yes, correct. with one more items and you can do something about it, you start from that side, right? It's very hard to start from the right side. Start from the left side, you have a standard procedure to follow, right? Remember the standard procedure I have repeating? I say whenever you see cotangent, change to cosine over sine. Whenever you see cosecant, look at the third alphabet, you change to 1 over sine. Then after that, again, you see the two fraction. What do? You take common denominator. Am I not repeating? I'm doing the same thing right now. So nothing new, really nothing new. So if you find that you do have some problem proving identity, try to follow the steps over and over again, the same thing, you know. So if you do encounter some difficulty, let me know. Then I will tell you how to approach it. Not all the question 100% the same, but very slight different, okay? At least you can handle 90% of it with this method I taught you, okay? Okay, see, now, that is my left-hand side. Now, one trick is that don't expand first, all right? Take common denominator first. That's something come from experience, because you try to expand, then you get cosecant square, you got cotangent square, you got 2 times cotangent cosecant. Oh my God. I'm not familiar with it at all, right? But you're definitely more comfortable with sine, cosine. So please change to sine, cosine first. Do something that you're comfortable, okay? Change to sine or cosine that you feel very at home right now. Sine, cosine, tangent, you're more familiar with what cotangent, cosecant, what secant, all this very new to you right now. Okay. So after you change to sine, cosine, don't expand first because expand will make it complicated. So why don't we just take common denominator here? Okay. Try. Now, secant, the third alphabet is S. Hey, you have the same denominator, right? So you just write down sine. And the top one is just cosine x minus 1. But don't forget the square. So when you have a square, what you do? You square the numerator and you square the denominator. Yes or no? Okay, I'm going to stop here for a while because my handwriting is very big. All right. So I got no space. Okay, let's continue from here. See whether we are getting this. Is there any closer? So what do? Expand now, correct now? You got the square, you expand it. Cosine square minus 2 cosine x plus 1, right now? Yes. And then the bottom is sine square x. Yeah. Does it look familiar? Okay. All right. Okay, how to continue from here? Can you still do something about it? Can you still doing something about it? You take a look at the right-hand side. Eventually, you want something like that. The denominator is cosine right now, but you have sine. You have sine square. So what do you do? What do you do? How to change sine to cosine? Remember the bridge? So you still write down, change it to 1 minus cosine square x. Yes or no? Okay, then cosine square x minus, this one I can't do much over here. I have no much idea here still, but the 1 at least is there, right? You can see the 1, and then you have a 1 here. All right, let's see what I can do with this. Now, why do people say, let's go back, why go back to square 1? Square 1, isn't it 1 is the same thing, right? Can I put a square here? Correct. So I get 1 minus cos, I get 1 plus cos. Does it look better now? Does it look better? I got a squared minus b squared, right? So it's a minus b, a plus b, or you want to put a plus b, a minus b is okay. Either way, all right? Commutative, right? Commutative means 2 times 3 is the same as 3 times 2. That's called commutative, right? Can switch, right? For product is commutative. All right. So is it any closer? Yes. I will find some way to cancel 1 minus cosine, then I will get the denominator as 1 plus cosine, isn't it? Am I not getting closer? Right? Good. Let's see what I can do here. How to cancel 1 over cosine? After I expanded this. Can I change to 1 minus sine? Or can I change this cosine square x minus 2 cosine x And then plus 1. Can I change it to sine square x plus cosine square x? Not so good, right? I still cannot get this. Oh, see what? Let's try again. Let's try. And I think the denominator is okay now. Yeah. Okay. How to cancel this off? This cosine square x minus 1 over cosine sine x. Yeah, I think it's okay. Okay, so how to cancel this off? If I take out cosine, or I can just leave it. In fact, I don't need to expand, right? Why should I expand? I no need to expand, okay? I will just have this as, I already have gotten 1 minus cosine. Why should I expand? Oh my God. Okay, I can just leave it, right? Correct or not? I just noticed here. I no need to expand. So no hurry, yeah? Why should I expand? I expand, I can't see anything. So I do learn something from here. I don't want to expand. Just now I already gotten this. Isn't it like this? I can cancel already, right? So why should I expand? Okay. So don't you don't you know that it actually the same, right? Do you realize that these two are the same? Okay, why are they the same? Hold on. Okay. You can see that I'm doing something on the spot. And then I'm showing you how I think over here. Now, a minus b bracket square, isn't it the same as b minus a bracket square? A few ways you can look at it, all right? So you can minus a minus b, right? You can do like this, isn't it? So when you square the minus 1, isn't it the same? The same right now. So a minus b bracket square or b minus a bracket square, they are actually the same. So I can just write like that. Isn't it my answer already? I've gotten my answer, just cancel this off. So I gotten this answer. Yeah, see? Now I do get stuck sometimes, but I want you to see how you can get out of that. So just now, because I expanded, why should I expand after I want to factorize back? Because I know I need to cancel off 1 minus cosine x, isn't it? So I realized that I shouldn't have expanded, right? Just now I already gotten that. So that tells you it's better that you put in factorized form. Especially you take a look at your right hand side. You have already gotten something here. Isn't it the same as 1 minus cosine x? Because you take out the minus 1, you take out another minus become plus, then these two are the same, isn't it? Isn't it the same? So today you do learn something here. If you don't realize it, now you should know that a minus b bracket square is the same as b minus a bracket square. They are the same, right? Correct. I already explained just now. If you don't believe, you can just expand. You notice that they are the same, isn't it? Correct. This b squared minus 2ba or ab doesn't matter. So you still get the same answer, right? Now, yes? Okay. With that, I have already completed D. Yes? Am I going too fast? Cannot. I still couldn't get any answer. Then I better come back to here. You better give me a thumbs up, or you tell me if you have any problem. Okay. Now I'm going to stop here for a while. Okay. Oh, I see all the thumbs up. Okay, that's good. That's good. This is why you all like thumbs up. I got to stop and come back, right? Okay, thumbs up then. If not, you just send me one. I see, okay. You send me a private message one, or you send in the chat group one, then you show. Then I know I come out again. Okay, let's go back. Okay, can I? All right. That's confirmed that you have heard me. Okay, what do I do here? I have another one, right? Here. I send you another one here. Let's try this. See, is this any a little bit harder, but no double angle still. Later I send you some double angle, all right? Okay, I think this is also quite easy. You just follow, okay? Now, trigo identity, you need to practice just like any other topic. You really need to practice. And I love trigo identity. You believe me, that is the first question I usually want to do. Because you already got the answer there. If you can prove it, then happy, you definitely get the marks already. Sometimes after doing a question, you're not so sure whether you do it correctly or not. But proving identities, one, you can prove it. Most probably, I think 95% or 99%, you get the marks already, right now. Correct. Now let's try. Okay, why don't you do together with me again? Okay, write down, huh? Write down. I take this away. This too easy now. Okay, you do first. I try to find some more question with double angle. Okay. Okay, I think this one you shouldn't import. Or maybe you can just send me your answer, your working. Is that okay? Can I? You can private message me or you can put it in the chat group. Like in the time being, I find some proving identity using double angle. Okay. Now this is still, you can see it's still quite easy one. Just follow the method I show you. This should be okay. Try them out, please. Okay. I choose some question and I continue sending it to you as you are doing this question. Send me your answer. Or you can just tell me which question you have problem with. I will do it. I will do it online, okay? I don't receive any question that means all of you can do all of the A to D. Cannot. Can I assume that? Okay. Let me send you some more double angle formula proving identities. In the meantime, please do something about it. I don't want you to be audience, sit down there and just listen. You want to be participant, okay? As I always tell you, you must be participant. Don't be on audience, just sit there and listen. You try it out, okay? Try out. I will send you some questions involving double angle. Identity is so important because if you cannot do proving of identity, then you will affect you solving trigo equation because you need to simplify, okay? Before you can get the answer. All right, I get you some double angle identity. Please continue doing your 8A to 8D. Let me know if you have any question, any difficulty with question 8A to D.